Let's talk about permutations and combinations. So I'm going to talk about 4 different conditions. One, I'm going to talk about permutations with repetition, permutation without repetition, combinations without repetitions, and combinations with repetition. And I'm talking about these in this order because it makes sense logically as I explain how to come up with it. So for all of these situations, let's describe 4 distinct, different, unique objects, and we're picking 3 out of them. So for all of these examples, from 4 objects, pick 3. So an example here, I'll just label them as A, B, C, D from a set of 4 elements. Pick 3. But this picking 3 can have multiple meanings. The first meaning we'll discuss is to pick 3 where order matters and allowing for repetition. This is called permutation with repetition. So if I pick A, B, C, this is different from if I say C, B, A. And also because I'm allowed to take a repetition, I can pick A 3 times or A twice. So how many different possibilities? The first one, I have 4 possibles. I can pick A, B, C, or D. Second one, I can pick 4. Third one, I can pick 4. If I pick A for the first one, the second one, I have 4 options. If I pick A and then A again, I have 4 options again. And you can see that basically it's 4 times 4 times 4 again. So if I had more elements, this would, if I had 6 elements, then this would be 6 times 6 times 6. Basically, I'm going to set n equals 4, r equals 3. N is from how many objects, and then r is how many I'm going to pick. So for permutation with repetition, it is n times n times n. In other words, n to the r. That is, if I want to pick 3, and how many ways can I pick 3 objects where order matters and I can repeat? Now what if I cannot repeat? If I cannot repeat, then I have 4 options for the first one. Second one, for example, if I pick A, I can't pick A again, so I only have 3 options. And the third one, I only have 2 options. In this case, 4 times 3 times 2. Let's say instead of picking 3, I'm just picking 2. So if I just pick 2, then it'll be 4 times 3. Let's change the numbers here. Let's say we have a total of 10 elements and we want to pick 3. So the first one we have 10, second one we have 9, third one we have 8. If I keep writing this times 7 times 6 all the way to times 1, this is known as 10 factorial. Because I'm removing this 7 times 6, this is 7 times 6 times 5, I'm dividing this number by this number in order to just get this. So this would be 10 factorial over 7 factorial. Where do I get the 7? The 7 is just from 10 minus 3, 10 minus 3, 10 minus 3 factorial. So I can write this as n factorial over n minus 3, n minus r factorial. So if I want to pick 3, and the order does matter, but I cannot repeat, then what I get is the different ways I can do that is n factorial over n minus r factorial. So now let's talk about combinations without repetition. Combination is how many ways can you pick 3, but now the order does not matter. So if I pick A, B, C, it is now the same thing as C, A, B in terms of these are not different combinations. This is just one combination. These are all part of one combination. So then the question is, how many combinations can I get? In order to find that, what you recognize is if I write, if I pick ABC, right? If I just pick the number of permutations without repetitions, ABC, the different ways I can order ABC, BAC, or BCA, or CAB, or CBA, or ACB. What you realize is that how many ways can I order this? I can order this a bunch of different ways. So we have a lot of these possible permutations, but for every 3 letters that I choose, there is a bunch of options that are basically the same thing. So all these permutations basically squeeze down to just one combination. So what is this? This is just how many ways can we rearrange 3 things, right? And we already know how to find the different arrangements of 3. It is just 3 factorial. So, however many we pick, we just need to divide by how many different ways we can arrange this thing. So it's the same thing as permutations without repetition. So 3, choose 3. If we have 3, how many ways can we arrange 3 objects? It would be 3 factorial. 3 minus 3 factorial is just equal to 3 factorial. So basically, we just take this permutation without repetition, and however many permutations we have, we just divide by how many ways we can rearrange however many we picked. That's r factorial, because if we pick 3, then how many ways can we arrange 3? If this was 4, then we would have a lot more arrangements, and this would be 4 factorial. So basically this ends up as n factorial, r factorial, n minus r factorial. So the last one, combination with repetition, is how many ways can we, how many combinations can we get if we can repeat. So in order to do this one, I'm going to kind of draw a mental picture. Pretend these 4 elements is like 4 different ice creams we can get. Let's say this is vanilla, chocolate, strawberry, I don't know, peach, whatever. 4 flavors of ice cream. And then you start in this first position, and you can either take a scoop of ice cream, or you can move over to the next position. And when we have a combination, for example, let's say I want if we want 3 scoops of vanilla, that's one combination with repetition. It will be the same thing as if I get 1 chocolate and then 2 vanilla. No, sorry, these two are different. But if I get chocolate and 2 vanilla, it will be the same thing as if I get 2 vanilla and then 1 chocolate or whatever. So what we'll realize is the only way we can get one combination with a repetition is through one specific sequence. For example, let's say I want to get 2 chocolate. Let me rename these. No, but this will be vanilla. Let me name this VCSP. Okay. Let's say I want 1 chocolate and 2 strawberry. 1 chocolate, 2 strawberry. In this case, if I'm going in order, there's no way I can get the strawberry first and then the chocolate and then another strawberry. So by thinking about it in this way, I'm forcing basically a combination instead of a permutation. Because I'm saying no matter what, I have to get this chocolate first. So what we'll recognize, let's say I want 1 vanilla and 2 chocolate. So I start here, take a scoop, then take 2 scoops here, and then I move over. I turn this into a sequence. It looks like this. I'll translate to this. So this is the same thing as the combination of 1 vanilla and 2 chocolate. There's no other sequence here that'll give me 2 chocolate because I can't move backwards. Okay. Now if let's say I want just 3 peach, that I would move over, and then take 3 scoops. So I write out that sequence like this. This is 3 peach. There's no other sequence that can give me 3 peach. Or let's say, 1 vanilla, 2 peach, 1 scoop, move over, 2 more scoops. This is the only sequence that can give me 1 vanilla and 2 peach. And what you'll see is that each of these is one combination with repetition. So I can get 2 chocolate. I'm not just forced to get 1 chocolate. Each of these is one combination with repetition. So all we need to do, find how many ways we can write this sequence. So if you think about this, how many ways can you write this? I can write it like this. I can write it like this. There's many ways. But what we'll see is we're choosing 3 positions to put the scoops in. And the thing is, we already know how to choose 3 positions. Choose 3 positions to place something. That is combination without repetition. So out of 6 positions, we are choosing 3. So another way to write combination without repetition is NCR. This is what you'd find on your calculator. Another way to write permutation without repetition is NPR. So in this case, all the ways we can write this sequence is choose 3 positions out of 6 for our scoops. Why is it not permutation? You can think of 6. What are all the ways we can arrange these 3 scoops? The reason is because the order of the scoops don't actually matter. So let's say I choose this position here, and then I choose this position here, and then this position. So this is one permutation. But the thing is, if I choose this one first, and then this one, and then this one, here we're counting two possibilities, but as you can see, this is just the same thing. This is the same sequence. So this is why we're not using permutations. But what we're doing is we're choosing 3 positions. We're taking a combination of 3, where the order does not matter, and we cannot repeat the same position. So that's why we're using 6 choose 3. So this is really, we know the formula for that. 6 choose 3. 6 minus 3. Okay. So this is the answer, but where did 6 come from? Where did we get 6? 6 is the total positions that we can put our scoops. So why is there 6 here? 6 is because we're taking 3 scoops and we have 4. How many times do we have to move over? It's the number of different flavors we have minus 1, because we only have to move over 3 times. So 3 scoops, remember scoops is our R, right? And then the total amount is equal to the number of times we have to move over is n minus 1. So in total, the positions here, R is the number of scoops, n minus 1 is the number of times we move over, and so the total number of positions is, I can rewrite this as n plus R minus 1. So that's where this 6 comes from. So but now we know this answer already, but to write it in terms of n and R, we do this. Now we know this is R, and then we know this is n plus R minus 1 minus R. So now you just see this cancels out. So this is equal to n plus R minus 1 R factorial n minus 1 factorial. And so those are the equations for permutations and combinations.